Yo, what's up, y'all? I just want to briefly go over a little bit of what I did this weekend, just so that we're kind of on the same page. And honestly, this would be a good reference video because I will probably forget most of what I did here. Um, but anyways, I didn't go that far ahead. I did do a decent bit of stuff, but it's not really stuff that's like, it's like extra features kind of things. Like I made a console class for implementing like different console colors and stuff, which a lot of this code is actually reused from the project from last semester. So the only stuff that I really kind of worked on and like added to this was all of the debug stuff. Um, so it's not like it looks like a lot of code, but a lot of it is really just stuff that is just bells and whistles. Um, But the things that I did work on that were not bells and whistles, that were actually kind of core to the project, are first and foremost, I think one of the best changes that I made for at least what I was working on was moving the entire game, like, basically to its own class. I tried doing this weird mishmash of having like the main game methods and like game settings be all inside of the main class, with the main method and everything. And it was just getting really, really cluttered. And then there was some weird like overlap logic and issues with access modifiers, and it was just kind of really annoying. So I moved the entire game application to its own class. And another cool thing about doing this is that this kind of makes it so that we can run multiple game applications at the same time. So um, it's not just kind of like a code cleanup thing, but it also gives us some extra functionality too, which is pretty cool. I might be able to give an example of that once I start running the code, just to show you like how it looks now. But that was the like one of the biggest changes. So everything is now in this game class, which I'm trying to think of what else I want to go over here. You'll notice a lot of like extends application um, lines of code, like pretty much towards every single utility class or um, pretty much every like top level class. That's because I found it to be really useful to have like kind of a really high level base class that just holds like utility methods that are available globally throughout the application. So, for example, like this tick function right here, which just returns like the current timestamp of Unix time. So this is like your actual local time on your computer. Um, and like a wait method so that this will actually stall the current game thread for a certain amount of seconds. So we don't have to keep implementing this like try catch block every time we want to wait. So that's at the top level, which means that like if you go to any class that extends application, which should be every class, probably with the exception of the game settings class. Like let me go to movement frame here. Movement frame extends frame processor, but frame processor also extends uh, application. So if I go to like movement frame, for example, if I just go inside one of these methods and I start typing like tick, you can see right here that we actually get access to that, and it shows that it's coming from application. So that's pretty neat. Um, so that's kind of what that is. The other biggest thing that I did was kind of finalize the game loop logic, which I kind of was already done, but there was some issues with making it so that uh, we could run multiple different simulation frames kind of at their own pace, because movement frames are obviously going to run at a different frequency than render frames. Render frames being the actual graphics update that repaints the GUI like every so often, and a movement frame is going to be what calculates all of the movement calculations for the bugs in the simulation, which is going to be a big task. So that code is going to go here in this movement frame step method once that's done. And then once we have someone do the um, write the code for all the graphics updates and stuff like that, that's going to go in the step method for the render frame. You also notice this simulated lag frame here. This is really just like a test frame. So this kind of just creates some artificial lag so that we can kind of see a little bit more clearly like what's going on once we actually run the program. I think I already went over the console thing. Um, I think that's pretty much it. I guess I can briefly cover the frame processor. This was probably the most annoying to work on because um, I essentially wanted to kind of localize and generalize like all of all of the timing logic for each of the simulation frames. So that's why the movement frame and render frame and all the other ones can kind of just look like this and be really like kind of neat and not a lot of code. And that's because all of the like debounce logic is kind of being handled in the frame processor. So I guess I'll just go ahead and run it so you can kind of see what it looks like now. It's pretty much the exact same visually as it was before. I obviously haven't done much uh, or anything really with the GUI stuff, but you'll see in the console, we finally have our color coding again, which nobody cares about, but I'm strangely like a really big nerd about that. So that's cool. I'm gonna stop this now. But in the console, it makes it much more clear kind of what's going on. So you know, all of the like the render frames and the simulated lag frames are all running at the same frequency, so they're both 1/60th of a second. But then every so often, every 1 second actually, we should see a movement frame right here. And you can see that uh, the last simulation of that frame was 1 second ago. Um, and really, this should be a 60th of. Oh, wait, no. I have like an artificial weight in here. If I remove this, we should see that the render frames and the simulated lag frames should be running at close to a 60th of a second, which is it should be about this. So something close to this, 0.016. Um, let's see if we get that. Just close that. So there is a little bit of delay. I did have to compromise. Uh, Actually, that's kind of weird. That's a bigger delay than I would have been comfortable with. It's about, 0.004. Oh, you know what? It's because never mind. Um, it's because I'm printing all this stuff to the output. I bet if I go back to this and I like comment out, let's comment out. No, actually, let's do these two. Okay, now if I run this, yeah, it's a little bit better. So it's just because we have the print statements. Like the console debug printing is kind of an expensive operation, which makes sense because there's kind of a lot involved. Like it has to calculate the console colors and everything. Um, so if debug mode is off, then this runs a lot faster. But you can see that these are like much closer to the values of 0.016. So everything is working. There's no frame skipping, so everything is pretty much still working in perfect order. Um, and I think that's really about it. I guess one more thing that I should mention really quickly is that I guess just like for a GitHub tip, real quick, I would go ahead and star your project probably. So if you click on the link to the GitHub repo that I think Jalen posted in the Discord, Um, then once you get on this page, you can I forget where it is. I think you can just click on this to start it. You can also like watch it too to get notifications when things get changed. Um, so I would probably do that just so you have like quick reference to it. And also, I don't know if I think I mentioned this to Jalen, but I did start making some branches, and it looks like Jalen did too. So you know, I think like generally speaking, we really don't have to worry that much about GitHub branches. Um, I don't think there's really enough time to kind of get into it, but I was thinking we could at least have maybe a branch with each of our names on it, so that as we're kind of working on our own tasks, we don't really step on each other's toes too much.